Hi there, welcome to the demonstration of our product ZigB232. This is a ZigBee to RS232 converter. This product comes in two parts, the hardware and the associated configuration utility software. The hardware is a compact plastic casing with mounting flanges for easy wall mounting. It also has 4 LEDs and 2 push buttons. The first LED is to indicate the power on status of the device. The second and the third LED is to indicate whether the device is functioning as a ZigBee coordinator or ZigBee router device respectively. And the final fourth LED is to indicate any ongoing data flow, data traffic on either the ZigBee or the RS232 channels. It also has two inbuilt push buttons. The first button is to put the device into the configuration mode, and the second button is to reset the device back into normal mode of operation. It also has an integrated SMA antenna for long range of communication and also for better performance. It has a USB port. It has a USB port which can be used to connect to the computer for configuration purpose. It has a terminal connector to make the RS232 connections, and it also has a 2-pin terminal connector to provide the power input. The power input can be anywhere from 9 to 36 volts DC. So in this demonstration I would like to use 3 such ZigBee232 devices and demonstrate wireless communication between them over ZigBee. Before using this product, the device has to be configured according to our requirements. This can be done by using our ZigBee232 configuration tool. This configuration tool is freely downloadable from our website. If the tool is successfully installed in your computer, it will have a shortcut created on your desktop which looks like this. So if you invoke the configuration tool, it opens up like this. I have invoked 3 instances of this configuration tool corresponding to the 3 devices that I would like to use in my demonstration. So these are the 3 instances of the configuration tool. The first instance is to configure the first device, second instance is to configure the second device, and the third one is to configure the third device. So let me show you the configuration settings that I would like to make for my first device. So as in any ZigBee network, there should be one coordinator device in the network. So I would like to make my first device as of device type coordinator with RS232 capability. So we have to give a unique number or name to the network, ZigBee network. So I am giving the name Q for my network of 3 devices. The channel number or the frequency that I would like to use for ZigBee communication is channel number 19. Since it is a coordinator device, I need not give any unique name to the device. So our ZigBee232 device supports 2 modes of data communication, that is transparent mode and point-to-point mode of operation. So in this demonstration I would like to demonstrate transparent mode of data communication. The antenna power of the device is also configurable, and I am selecting 19 decibels as the antenna power for my device 1. When I provide the data to my device 1 through the RS232 port, the baud rate I am going to use for RS232 data is 9600. It is configurable, so I am selecting 9600 for the RS232 data that I am going to provide to my device 1. So I have configured the desired settings in this GUI tool, which I would like to download to my device 1. So the next step is to plug the device to the computer to the USB port and then download the settings into the device. So for that I am plugging the USB cable of my computer to the USB port provided on the device. So you can see the device powers up, the power on LED is on, And now let me find this device on my computer. So I'll go back to the GUI tool and I'll click on find. So the device is not yet detected. Let me find it again. So it is detected as virtual COM port number 6 by my configuration tool on the computer. Now before downloading the settings into the device, I have to put the device into configuration mode. For that, we have to use the two inbuilt push buttons. To put the device into configuration mode, I have to keep the config button pressed and apply a reset through the reset button. So keep the config button pressed and I apply a reset on the reset button. So the device is successfully put into configuration mode. This can be observed by the three LEDs. If the three LEDs are simultaneously on, it indicates that the device has entered into configuration mode. So here you can see all the three LEDs apart from the power on LED are on simultaneously. So this device is now in configuration mode. So the next step is to connect to the device from my GUI by clicking on the confirm button. So the device is successfully connected to this GUI and now I can start sending the data. Notice when I click on the send button, the three LEDs will start changing states, indicating that the configuration data is being downloaded into the device. You can keep observing. You can keep observing these LEDs as I click on the send button. You can see the LEDs are changing state. So the configuration settings are being downloaded. So the configurations have been successfully downloaded into the device 1. So I have successfully made the first device as ZigBee coordinator with RS232 capability. So the next step is to bring back the device out of configuration. That can be done by resetting the device. You can see when I reset the device, the blue LED starts blinking, indicating that it is trying to make or form the ZigBee network. You can notice that. And it becomes stable once it is successfully able to form the ZigBee network. So this device is now a coordinator device and it has successfully formed its network of name Q. Now let me do the desired settings for the other two devices. So let me show you the settings that I would like to make for the other two. So before that, let me disconnect the first device from my computer. So the second device cannot be a coordinator. In any ZigBee network, there can be only one coordinator. So I will make my second device type as router with RS232 capability. Network name should be same because all the three devices should form and join the same network. So the network name is Q as earlier. And the channel number or the frequency that I'm going to use within the ZigBee band is channel number 19, same as earlier. Since it is a non-coordinator device, we have to give a unique number or name to each of the devices. So I am giving the unique name J for my second device. And again, the mode of communication data transfer is transparent mode of communication. And the antenna power I am configuring for my second device is also 19 decibels. So these are the settings I would like to download, and when I feed the data RS232 data to my second device, I'll be providing it with a baud rate of 9600. So that is what I am configuring into my second device. So I am ready with the data configuration data to be downloaded into my second device. So I can plug the device to the USB port, find it on my virtual COM port, and put the device into configuration mode using the configuration button and start downloading the data. To save time in this video, I have already downloaded the settings into my second device. So these settings are already there in this device. So the second device is also successfully configured. So let me show you this device configurations that I have made for the third device. So again, this device type is router with RS232 capability. Network name is same as earlier, that is Q. channel number is same as earlier, that is 19. The node name cannot be the same, so I have given a unique different name to my third device, that is K. And the mode of data transfer we are using among these three devices is transparent mode of operation. And the power level that I have configured for antenna for my third device is 19 decibels. And when I feed the data into this third device, I am on the RS232 port, I am going to provide it with a baud rate of 9600. So that is the configuration that I have done. So I can power on this third device by plugging it to the USB port of my computer, find it on my virtual COM ports, and start sending the data. To save the time in this video, I have already downloaded the settings into my third device. So these are the settings already downloaded into my third device. So one device has been made as ZigBee coordinator device and two devices as ZigBee router devices. So now the next step is to demonstrate the wireless communication among these three devices over ZigBee. To feed the RS232 data into each of these devices, I am going to use Docklite software utility on my computer. So I am going to use 3 instances of the Docklite software utilities corresponding to the 3 devices I am using in this demonstration. So this instance of Docklite is to feed the RS232 data on my first device and observe the data coming on its RS232 port. So this is the coordinator device. So the data I am going to feed into this device is a string called from coordinator. So I have already prepared this string and I have kept it ready. So similarly for my second device, I have second instance of this Docklite utility, and the data I am going to send from this device on its to its RS232 port is a string called from slave1. So similarly a third instance corresponding to the third device. So this is the third instance, and the data I am going to feed into its RS232 port is a string called from slave2. So this instance of Docklite represents my coordinator device, first device. This instance represents my router, the second device. This instance represents my third device. So the next step is to plug each of them and start finding them on the corresponding instances of Docklite. So let me plug the USB cable of my computer to the USB port of the first device. So it is powered up, and you can see the blue LED is on, stable on, indicating that it has become a coordinator and successfully formed a ZigBee network. So now let me go to the project settings and detect the COM port. So it has been found on virtual COM port number 6, and as configured I have to use a baud rate of 9600 to feed this RS232 data into the device 1. So the baud rate is 9600. So same way, let me go to the second device and plug the USB cable to its USB port. So as I plug it, you can see the power on LED is on, and also the device is of type ZigBee router. So the green LED is on, indicating that it has become a ZigBee router and it has successfully joined into the network formed by the coordinator. So let me do the same thing for the third device. Before that, I have to go and find the second device on the computer. So if you see, it has been now found as COM5. The second device has been counted as virtual COM port number 5. So I'm going to select that, and I'm going to use the configured baud rate of 9600. This is what we configured for the second device through its configuration tool. So I'm going to say OK. So second device is also found and is ready on second instance. So I'm going to do the same thing for the third device. I'm going to plug the USB cable of my computer to the USB port of the third device. You can see the power on LED is on, and also the green LED is on, indicating that this device is also a ZigBee router and it is successfully joined into the network formed by this coordinator. So we have one ZigBee coordinator and two ZigBee routers. So let me find a third device on the third instance of the Docklite. So I'll go to project settings, and you can see the third device has been found as virtual COM port number 4. And the baud rate we had configured for the third device for RS232 data is 9600. So that's what I'm going to set here. So I'm going to say OK. So the left hand side, the first instance of Docklite represents my ZigBee coordinator device, that is this device. The second instance of Docklite, that is this one, represents my second device, that is this, which is the ZigBee router, and the third Docklite instance represents the third device, that is this one, which is again a ZigBee router. Now any data I feed from my first instance into my first device will be wirelessly transmitted over ZigBee, and it can be received by the other devices. So before demonstrating that, let me quickly show you what is the transparent mode of data communication. So let me go to our user manual. So these pictures depict the transparent mode of data communication. So in transparent mode, the coordinator device works in broadcast mode of operation. That is, any data given to the coordinator device will be broadcasted to all the other devices on that network. So the data broadcasted by the coordinator will be simultaneously received by all the other devices on the network, and any data provided to the router device on its RS232 port will be unicasted only to the coordinator. That is, data coming from any device will only be received by coordinator device. So this is the transparent mode of operation. Coordinator broadcasts the data to all the other devices, and any other device can only unicast the data only to the coordinator device. So this is the transparent mode of operation. That is what we have configured to all the three devices. So now let me connect each instance to that particular zigB232 device. So this is the string I would like to provide to my device 1. This is the string I would like to provide on RS232 to my device 2, and this is the string I would like to feed to the third device on its RS232. So when I click on send button, this string will be provided to my first device, which will then transmit that wirelessly over ZigBee over the network. And since the coordinator is in transparent mode, it will broadcast the data, and that strings should be received simultaneously by these two instances. So let me try that. So you can see as I transmit from the coordinator, the data is simultaneously received by the two other devices, because coordinator will broadcast the data to all the other devices. So let me clear the windows for easy visualization. Now if I send the data from router 1, this particular string has to be unicasted only to the coordinator, and it should not be received by the other device. So let me try that. So you can see that particular string is transmitted by the router device 1, second device, and it is unicasted and received only by the coordinator. It is not received by the third device because it is a router. It does not receive the data. So let me clear the windows again. So let me try to send the data from the third device. So it is transmitted, that is unicasted from the third device, which is a router, and it is received only by the coordinator. At the coordinator, it is not received at the other device, which is a router. So let me clear it. So let me do again. So this is broadcasted from the coordinator and received simultaneously by the other devices. So when I send from here, it is unicasted from here, and it is received only at the coordinator. If I send from here, it's again unicasted from the third device router, and it is received at the coordinator. So this is how the transparent mode of communication works in our device. So let me put this data transfer into periodic mode of operation. So I want to transmit this data from the coordinator every 2 seconds periodically. So same way I will make this data transfer also periodic every 2 seconds. And similarly the third device, I will make the data transfer periodic every 1 second. So now if I send the data from the coordinator, it will be continuously broadcasted, and if I put this in running mode, you can see the data will be received at the two coordinators simultaneously. It's received simultaneously by the two coordinators. If I send the data from the first device continuously, it's only received, the data from the coordinator is only received at the, from the router is only received at the coordinator. Similarly, the data I'm going to send from the third device, which is again a coordinator, is also received only at the coordinator. So data from coordinator is broadcasted and received at both the routers. Data from any router is unicasted and it is received only at the coordinator. So let me clear this windows and you can notice. So let me stop the communication. So this is about the transparent mode of operation in our device. The other mode of data communication supported in our device is the point-to-point mode of communication. So let me quickly show you how that works. So this picture depicts the point-to-point mode of data transfer. So in point-to-point mode, any device on the network can send the data to any other device on the same network, irrespective of the device type. So a router can send the data directly to any other router or the coordinator. Similarly, the coordinator data can send the device can send the data to any other router device. For this, the data packet should have the target node name or address in the first byte of the packet, the length of the data in the second byte, and the actual data in the following bytes. So this is the packet format to be followed when using point-to-point mode of data transfer in our device. So this is about our product zigB232. For more details about our zigB232 product and also our various other products, please visit our website tangentTechnolabs.com. You can also reach us at contact@tangentTechnolabs.com for more details. Thanks for watching this video. Bye bye.